pre1 is simply true. What is true and x is greater than y? Is there a way to simplify it? Exactly. It reduces to x is greater than y. How can I do that? I mean, this is simplification of a Boolean expression, but how do I know that, I can do something like that? It has to do with the definition of the conjunction operator, okay? If you go to the module that talks about conditional statements, we define what is a conjunction. Do you guys still remember that? Now, how do we define a conjunction? A conjunction is defined by its 4 possible combinations of left-hand side and right-hand side. True and true is true. True and false is false. False and true is false. And then we have false and false being false. Okay, great. But how does this have anything to do with going from here to here?
So your space true states that both sides have to be true in order for that whole statement to be true.
Exactly. But on top of that, these 2 rows are specifically important. So that I can say something like that. Because these 2 rows illustrated with all the possible input you can throw at a conjunction. If the first one is true, okay, then whatever the second one is going to be the result. It is just like 1 times 5 is 5, 1 times 10 is 10, 1 times 7 is 7. In this case, it is a lot easier. It is simply saying true and true is true, true and false is false. If one side is true, the expression preserves the other side. In algebra term or abstract algebra term, we call true the identity value with respect to the conjunction operator, which is a fancy way of saying, 1 times whatever is whatever. Okay? Are you guys convinced that this derivation or this simplification is sound? It is valid? Okay. So we'll just put this aside, because it is just an explanation of why we can do that. Okay, so now that we know what is pre-2, we can do the same thing and find out what is pre-4. So I will just kind of jump around a little bit and go to pre-4 instead of post-2 at this point. Pre-4 is pre-1 and not x is greater than y. Does that make any sense? In other words, I'm now talking about here, we are about to execute line 4. Does it make sense that I can say that pre-4 is whatever pre-1 is, and on top of that, it is not the case that x is greater than y? Does that make sense? Yeah, because otherwise we would not be taking this branch. So now we can do some simplifications. Pre-1 is true, and the other way to say not x is greater than y is simply to say x is less than or equal to y. Okay? And because of we can do the same simplification, true and anything is that anything, so we can simplify this whole thing to x is less than or equal to y. Are we okay so far with pre-2 and pre-4? Okay. Now that we know pre-2 and pre-4, can we derive what is post-2 and post-4? Especially using what we just did a little bit earlier, the forget operation. Remember that? Okay. In order to understand what is post-2, we have to say, okay, step 1, the right-hand side of line 2 does not refer to the left-hand side, which means we have to use the forget operation. Use the forget operation. And that means we have to say forget whatever is in pre-2 that mentions anything of the variable on the left-hand side or right-hand side? The one being changed. The left-hand side, very good. And in this case, that would be z. But on top of that, we now know one thing that we did not know before, because after line 2, it is guaranteed that z equals x. Because the assignment operation makes sure that z will equal to x after it. Is that okay so far? So once we have this form, we can go ahead and expand what is pre-2 Pre2, according to this operation, is simply x is greater than y, and z equals x. Does x greater than y mention z at all?
No.
So do we get to keep it? The forget operation specifies if anything contains z, we don't get to keep it. We have to forget it.
Yeah.
But x is greater than y does not refer to z, so we get to keep it. Okay, we do not forget it, we get to keep it. So x is greater than y, we just keep the whole thing. And of course, we also know the other thing because of the assignment statement, and that's it for post 2. Okay, so here I can say use similar reasoning for post 4. So I would just simplify that to post 4 equals the forget operation applied to pre 4, and we also forget components with z in it because once again z is the left hand side of the assignment on line 4. But on top of that, we now know that z equals to y. So we just go ahead and expand what is pre 4. Pre 4 is x is less than or equal to y. But since x is less than or equal to y does not refer to z, we get to keep the whole thing. And that's it. Are there any questions about the derivation of post 2 and post 4? It's okay? Okay. The derivation of post 2 and post 4, as you can see, has nothing to do with whether it is in a conditional statement or not. It has to do with it is an assignment statement, and the right-hand side does not refer to the left-hand side. But the fact that one is in the then branch of a conditional statement, the other one is in the else branch of a conditional statement, doesn't change how we derive the post condition from the precondition. So that's something that you also have to remember is that. Now is the most important part. What is post 5? Okay. If I have to draw something in this picture here, post 4 is right after the else branch. Okay, that's post 4. This is post 2. Pre 2, statement 2, post 2. Pre 4, statement 4, post 4. Makes sense. This is our post 5. So the question is, what do we know for sure when we get to this point here? After the two branches merge, what do we know for sure? Sorry, go ahead.
X greater than
Okay, go ahead.
we have z.
We have z, but what can we say about z when we are here?
It's
We want it to be the maximum. We want to prove that it is the maximum, but
x is greater than it's equal to x or y.
Okay, we want that to be the case too. But in terms of this diagram, how does post 5 relate to post 2 and post 4?
It's
When
one
I-
of the other. It's one of them. It's not both.
Okay, now you're almost right. Okay, you're very close to the answer. When I stand here, okay, think of this as monopoly. So we go into the different paths, and when I'm standing here, I don't know, I cannot remember which way I came from. I could have come from the then branch, I could have come from the else branch. So when I'm standing here, I would just scratch my head and go, well, I don't remember which way I came from. I might have came from this way or this way. So how about I just say the post condition here is this guy or that guy?
Yeah.
Okay? Now, it's almost exactly the same as what you said, but what you said implies exclusiveness. Aha! So what he said was either post 2 or post 4 or something to the same effect. But the answer is simply post 2 or post 4, which is different. Or the disjunction operator states that at least one side has to be true for the entire thing to be true. They can both be true. There's no restriction saying that they cannot both be true. Okay? Exclusive or, on the other hand, when you say something either this or that, it implies exclusiveness, which means only one side can be true for the entire thing to be true. But in this case, it is not exclusive. It is just a simply or because I didn't remember which way it came from, I would just say that this condition or this condition. One of these two has to be true, but they can both to be true as well. I will show you a very trivial example of why they can both be true. Okay, so let me just finish this part first. So post 2 or post 4, and then we'll use some indentation here, because the next step is just copying and pasting some stuff here. So whenever I'm copying and pasting, like a big chunk of expression into another expression, I always use the parentheses first, so that way the order of operation is clearly indicated. If I did not use the parentheses, then it is not as clear. So I would copy post 2 into here. I would copy post 4 into here. Okay. I can simplify that a little bit if I wanted to, but I don't think I need to do that anymore. The question now is, I have just gone through the mathematical proofs to show that making no assumptions whatsoever about x, y, or z, because pre1 is true, I didn't know anything about the variables. And I get to this post 5, which states x is greater than y and z equals to x, or x is less than or equal to y and z equals to y. Does that say that z is a maximum of x and y? Okay. What are the properties of a maximum of two numbers? One, the maximum has to be the same as at least one of the numbers. Is that guaranteed here? Yeah, because one side says it has to equal to x, the other side says it has to be equal to y, and these two sides are joined with an or, which means at least one side has to be true at any time. Being the maximum also means the number has to be greater than or equal to both of those numbers. Is that guaranteed? Well, let's think about it. Okay, let's think about it. Let me just rephrase the question. The question is, can we guarantee at this point that z equals to at least one of the two numbers, and it is, okay, take it back. Can we guarantee that z is greater than or equal to both numbers? We already know it equals to at least one of them, which is good. But can we also guarantee that z is greater than or equal to both numbers? Well, let's just take a look at this one here. This one says that z equals to y, and y is greater than or equal to x. Is that good? Does that make z the maximum? Sure. The other one says that z does equal to x, and x is greater than y. Does that make z the maximum? Yeah. So in this case, we can actually prove that if this condition is guaranteed as the result of these 5 lines, we are guaranteed that z is the maximum of those two variables. Are we okay so far? In terms of the concept, in terms of why we are doing this and the advantage of doing this rather than throwing darts at it. Because when you think about it, testing your program using test cases, like individual test cases, it's like having a huge dartboard, and every single time you test it with a test case, you're just throwing a single dart at it. Okay? In this case, we are proving the entire dartboard is correct without throwing a single dart. Okay? Because the mechanism, the actual math and derivations are important, but so is the idea of why we are doing this at all. Is that okay? Is the big idea okay? Do you guys understand why it is important to do this? Because I haven't used a single test case to show that the algorithm is correct. When my boss comes around and asks, Tech, I don't really trust you. Are you sure this algorithm is going to work? Because if it's not going to work, I'm going to have to fire you. And I can just show my boss, yes, it is